Here are the answers for the section 10-12 assignment. Number 1, we need to do the distributive property. Multiply the 7 to both terms in the parentheses. 7 times negative 3 is negative 21. 7 times 4i is positive 28i. Number 5, divide both terms in the numerator by the 3. So 9 divided by 3 is 3, and then 6i divided by 3 is 2i. Number 9, this has the look of distributive property. 2i times 7 is 14i, and 2i times 4i is plus 8i squared. But remember, whenever you have the symbol I and it has an exponent, you have to simplify it. The I squared part is negative 1. So this is equal to negative 8 plus 14i. Remember that the real number term goes first and then the imaginary term in a complex number. Number 11. We are told that a quadratic equation has a discriminant equal to 27. Recall that b squared minus 4ac is called the discriminant, that the discriminant is the expression inside of the radical in the quadratic formula, and that if the discriminant is equal to a positive number, there are two real solutions. So number 11 asks us, what is the nature of the solutions? We can say there are two real solutions. The solutions are real numbers, not imaginary numbers. Number 13, let's say there's a quadratic equation, and when we're using the quadratic formula, the discriminant part turns out to be negative 6. If you get a negative number in the radical, then that equation has two imaginary solutions. The answers that we get are going to have the symbol I in them. Now the written assignment. We're asked to solve the quadratic equation. You can use factoring, completing the square, or the quadratic formula. This first one looks like it's going to factor, so that'll be the fastest way to do it. X minus 6 times x minus 3 is equal to 0. Then solve each piece. X equals 6 or 3. Next one. This time, I can't factor it. I can't think of two numbers that multiply together to make 3, and the two numbers that I choose combined to negative 1. So the only way I can think to do this is with the quadratic formula. A is 1, B is negative 1, C is 3. So we have y equals negative b. So that's a 1. Then plus minus. Inside here we have b squared. So that's a 1. Minus 4 times a. Fill in 1 for a. And then times c. Fill in a 3. And that's all divided by 2 times a, which makes a 2. Next step. Figure out what's in the radical. So 4 times 1 times 3 is 12, and 1 take away 12 makes a negative 11 in there for the discriminant. In the last chapter, when we got negative numbers in the radical, we would say no real solutions. But now that we've learned about imaginary numbers, we can find solutions. This makes 1 plus or minus I times the square root of 11, all divided by 2. Number 5, this is a quadratic equation, so let's make standard form. 3n squared minus 5n plus 7 is equal to 0. We could try to do factoring. It might work, it might not, or we can just use the quadratic formula right now. I'm going to use the quadratic formula. A is 3, B is negative 5, C is 7. So here we go. N equals negative b. That's a 5. Then plus minus square root. Okay, inside here, b squared. That's 25. Minus 4 times a is a 3, times c. That's a 7. This is all divided by 2 times a. So that's going to be a 6 down there. Next step, figure out what's in the radical. That all makes negative 59. So our answer is 5 plus or minus I times the square root of 59, all divided by 6. Number 9, this has the look of FOIL. So let's use FOIL. 5 times 6i is 30i. Now the outer product is negative 25. Now the inner product, 6i times 6i, that's 36i squared. And then last, 6i times negative 5, that's negative 30i. When you do the combining like terms, do you notice the 30i and then the minus 30i? Those are going to cancel away. So we have negative 25 plus 36 times negative 1, because the I squared is negative 1. So this is negative 25 minus 36, which combines together. The answer is negative 61. Number 11, we have squaring a binomial. So you can go 3 plus I times 3 plus I and do FOIL, or you can use our pattern. Square the first term, that's 9. Then double the product, that's 6i. And then square the last term, that's I squared. Is it done? Well, it's not done because we have I squared. And remember, I squared, that's just negative 1. So 9 plus negative 1 is 8, and then plus 6i. Number 19, take the things in the top and divide by negative I. But when you divide the 5 by negative I, you're going to get an I in the denominator, and that doesn't really help us simplify. We need to do something that will take the letter I right out of the denominator. And the technique is to multiply top and bottom by the conjugate of the denominator. The conjugate of negative I is a regular I. So in the top, we have 5 times the I plus I squared. And in the bottom, when you multiply, you get negative I squared. But what's I squared again? Remember how I squared is negative 1? So we can continue farther. In the top, the I squared is just negative 1. And in the bottom, we get the negative of negative 1. So this makes negative 1 plus 5i all over 1. So we might as well just say negative 1 plus 5i. Number 21, we also have a fraction, and in the denominator is the symbol I. We're going to simplify by multiplying top and bottom by the conjugate. That would be I plus 3. So you need to times the top by I plus 3 and times that denominator by I plus 3. In the top, 20i times I is 20i squared. 20i times 3 is 60i. In the bottom, we have FOIL, but we have that special case of FOIL where the outer and inner cancel away. So I times I is I squared, and then negative 9. Now we're not done, because remember, if you ever get I squared, that's just negative 1. So this makes negative 20 plus 60i over, what do you get down here in the bottom? What's I squared equal? Well, that's negative 1, so negative 1 minus 9 is negative 10. Negative 20 divided negative 10 is 2, and 60 divided by negative 10 is negative 6i. For the review assignment, we have to simplify. We have I to the 24th power. That is equivalent to I to the 4th times I to the 4th times I to the 4th, I to the 4th, I to the 4th, and I to the 4th. Another way you could have thought of that is that's equivalent to I to the 4th power raised to the 6th power. But the point is, the I to the 4th is just a 1. So 1 to the 6th power is just 1. Number 4, let's rewrite I to the 17th using I to the 4th like we just did. I to the 4th times I to the 4 times I to the 4 times I to the 4. That's 16 of them so far, times one more I. Every one of those I to the 4th is just a 1. So the final answer is I. Number 6, square what's in the parentheses. So I squared makes I squared, and then the square root of 7 squared makes 7. But since I squared is -1, this is -7. Number 8, we have the square root of a fraction. So let's separate top and bottom. Then in the top, because it's the square root of a negative, let's do the factoring technique where you go 5 times -1. In the bottom, you can leave it as square root of 8 for now, or you can actually start to do a little bit of work on it. That's up to you. In the next step, we have I times square root of 5 all over square root of 8. Now you can't leave the problem with a radical in the bottom, so let's rationalize. Times top and bottom by the square root of 2. So this makes I square root of 10 all over what? What goes down here? What's the square root of 8 times the square root of 2? That's the square root of 16. But the square root of 16 is just 4. Number 10, we have 7 times the square root. Now the -128 we can write as 64 times 2 times -1. The square root of 64 is 8, and 8 times 7 is a 56 out front. The square root of -1 is I, and there's a 2 in the radical. Number 12, we have 4 times, and then when you're doing the square root of a negative, use some factoring to separate out a -1 like this. Times, and then you can write I over here right now, or you might just leave it as -1 right now and fix it in the next step. So the square root of -1 makes an I, and then the 11 stays in the radical. The square root of this -1 makes an I. 4I times I is 4I squared, square root of 11. And then because the I squared is -1, this is -4 square root of 11. Number 14, the square root of -9 makes 3I, and the square root of -3 makes I square root of 3. So this is 3I squared square root of 3. But what's I squared equal? I squared is -1. So this is -3 square root of 3. Okay, next one. The square root of -2 makes I times the square root of 2. And the square root of 98 you might think of as the square root of 49 times 2. So in the next step we have I square root of 2 times 7 square root of 2. I times 7 is 7I, and square root of 2 times square root of 2 is 2. So the final answer is 14I.